In the previous video, I gave you an example. So now it's your turn to have a go. So given this here, differentiate inverse sine of 2x to the power of 4. So differentiate this here. Okay, and if you get a graph plotter and plot this, it will then give you this red line here. So yes, so notice that this red line here stops in the middle of nowhere here, and the reason for that is because if you look at this here, when you differentiate this, it will give you this. But then this thing here only makes sense. It only makes sense when you're in the domain of -1 and 1. You see, this thing here only makes sense when you're in this region here. Okay, well, it only makes sense when you're in this region. So when you come to differentiate this here, you're notice that up here. Hang on. Notice that up here, this bubble here is, well, this bubble here has to be in between -1 and 1. So when you come to differentiate this here, this bubble here has to be in between this bubble here has to be in between -1 and 1 here. So that bubble here has to be in between the two. So to this here. So this bit here, this bit here would be, hang on, divide both sides by 2 here. Take the fourth root. So this bit here, hang on, take the fourth root. So this bit here would be the fourth root of a half, and then this here would be the fourth root of, well, the negative version of it. Okay, so it's only valid. That's why it stops in the middle of nowhere. Well, anyway, given this here, find the derivative of this here, and you will probably, well, you're given this here, so you will have to use this one here. Okay, so use this to differentiate this. Okay, so hang on. Yep. So use this here to differentiate it. So press pause and have a go. Okay, so to do this here, hang on. So you're asked to differentiate this this thing here, but visualize it as a bubble here. So when you come to visualize it, if so visualize it as this. So hang on, looking at this here, it is 2x to the power of 4. Okay, but in your mind, visualize it as this: sine to the inverse sine to the power, inverse sine bubble, and then by using that formula earlier, it gives you this. But then you've got to, because this bubble here is a function of x here, you've got to differentiate the bubble itself. So yeah. So here, remember the bubble was what was it? It was 2x to the power of 4. Okay, so in effect, you're trying to differentiate this 2x to the power of 4. So when you differentiate this, it will give you this, which is 2x to the power of 4. But then because this bubble is a function of x, you've got to differentiate the bubble itself. Okay, so 2x to the power of 4 here. So that will then take you to here. So remember that this thing squared. Later on, we've got to square this. But let's just differentiate the bubble itself. When you differentiate the bubble itself, remember the bubble is 2x to the power of 4. So when you differentiate that, this then will give you the 8, and then x to the power of 3. Okay, so this block here remains the same, but then we just differentiate the bubble here. That will then give us this. Okay, so now let's tidy up this block here. Let's tidy up this bit here. At the moment, you've got 2x to the power of 4. So when you square it, it means get the whole thing and times it by itself. So you're timesing it by itself. So that will give you this here. Merge these two together. That will give you the 4 here, and then merge these two together. That will give you the 8 here. Okay, and then and then this here gets multiplied to the top. So this here is your final answer. Okay, and if you get a graph plotter, plot your original question here, and this is our answer here. And the blue line here is this bit here. Okay, and then have a quick glance just to check your answer. Okay, looking at the red line, looking at the red line, you can see that the gradient here is flat. It's 0. Now look at the blue line now. When x is 0, the gradient itself is telling you the gradient is 0. Okay, and then looking at the red line, if you take this point here, you can see it's really steep and it's negatively steep. So now looking at the blue line, it's really high and it's on the negative side. So that kind of makes sense. Now if you look at this region here, looking at the red line now, the red line here, hang on, looking at the red line here, it is steep here and it's positively steep. Now looking at the blue line, hang on, looking at the blue line up here, somewhere here, let's just say it's here. Looking at the blue line here, it is really high. The gradient is really high and it's positive. So it makes sense. So you have a hunch that this here is correct. Well, anyway, the derivative is given by this here. Okay.